right? Next problem, yes, x1 of t and x2 of t are two signals which are given. X1 of t's Fourier transform is x1 of j omega, and x2 of t's Fourier transform is x2 of j omega. So what is the question? You have to comment on what are the signals x1 and x2, are they real or complex or imaginary, and also we have to comment about their product. So let us first write down, by looking at the functions directly, what does that strike here? X1 of j omega, x2 of j omega. What is the first thing that strike? They are real, correct? Amplitudes of the Fourier transforms are real. Everybody, is that okay for you? Because amplitudes, there is no complex term, they are all real. And what is another thing which you notice? You notice that x2 of j omega is nothing but x1 of minus j omega, correct? So if you rotate x1 of j omega, you will get x2 of j omega. We will try to use these two informations, okay? Yes, so first let us write down what is asked. So x1 of t has x1 of j omega as the Fourier transform. We know that this fellow is real. That implies what? X1 of j omega is same as x1 star of j omega. So what will happen in time domain? So this implies we are going in time domain. X1 of j omega has x1 of t. X1 star of j omega is x1 star of minus t. Correct? X1 star of j omega will have x1 star of minus t. What is this property? Conjugate symmetry property. So this implies what? The signal x1 of t is conjugate symmetry. Conjugation is there, implies definitely the signal should be complex. So x1 of t is what? That fellow is complex. That is a complex function. With the same argument, x2 of t, okay, has x2 of j omega as the Fourier transform. Okay, this implies, just now we have seen that x2 of j omega is also real. So what does it mean? x2 of j omega is same as x2 star of j omega. In time domain, what happens? x2 of t should be equal to x2 star of minus t. This implies what? The time domain signal is a conjugate symmetric, and hence definitely the corresponding signal is complex. Okay, so x1 of j omega is real and x2 of j omega is also real. So what is that we have got? We have got x1 of t and x2 of t are complex. So what are the possible choices here? Choice A and choice C. So B and D, they are ruled out. Okay, so B and D are ruled out. Why? We have just now we have seen that x1 and x2 both are complex signals. Now we have to comment about x1 of t multiplied with x2 of t. Okay, so x1 of t multiplied with x2 of t. What is this fellow here? Multiplication in time domain. So what should happen in frequency domain? So frequency domain, the corresponding Fourier transform should get convolved. So you will get 1 by 2 pi x1 of j omega convolved with x2 of j omega. But in the beginning of the problem, what is that we have seen? x2 of j omega is same as x1 of minus j omega. Let us plug in that. So this is equal to 1 by 2 pi multiplied with x1 of j omega multiplied with x1 of minus j omega. Again, something should strike. What is that? Note that this is looking like x of t convolved with x of minus t. So what is that? This is nothing but autocorrelation function of x1 of j omega. Okay, autocorrelation function of x1 of j omega. What is the important property of this one? Let us call this as phi x1 of j omega. Okay, the term inside the square bracket, let us represent it as phi x1 of j omega. So what is that important property satisfied by autocorrelation function? This fellow is even, correct? We have seen this in our which chapter? second chapter, right? When we talked about matched filter, just before talking about matched filter, we talked about autocorrelation function and cross correlation functions. And for autocorrelation function, what is the important property? It is an even function. Okay, so our phi x1 of j omega is an even function, means the term inside the square bracket is even. So x1 of j omega is real and x1 of minus j omega is also real. So and hence autocorrelation function is also real. So what is that we got? We have got that the term 1 by 2 pi x1 of j omega convolved with x2 of j omega is what? Real and even. If the Fourier transform is real and even, what should happen to the time domain signal? This fellow also should be real and even. Okay, so definitely the product is real. X1 of t is complex, x2 of t is complex, but their product turns out to be real. So what is the final answer here? We have got x1 and x2 to be complex and the product x1 and x2 is real. Okay, the product x1 and x2 is real. Okay, so what is the correct choice? Correct choice is C. Okay, what does it say? X1 and X2 are complex. That's what we have got. And the product X1 and X2 is real. Okay, this is not correct choice. Okay, X1 X2 are complex, but he tells something about X1 and X2 and he says that the product is complex. Definitely that is not correct. Okay, so what is the right choice? X1 and X2 are complex, but their product is real. Okay.